Hi, my name is Mateo Martinez, and I'm a data scientist with Locks Digital Group. Today, we're reviewing the second of our four-part series on predictive analytic models and their respective recommendations as part of a email service provider tool for their digital marketers. This model specifically provides analytics on images used in digital marketing campaigns and recommends ways for a user to optimize that image and campaign. So we'll hop over here into this Jupyter notebook hosted in Google Collaboratory. If you want to review this on your own later, here is some instructions on how to run this in your own local environment if you have access to this repo folder. So beginning, the data we used to train this model was from the Stanford AI Lab repository, originally containing 16,000 images of cars that also had some metadata of the year, make, and model of that vehicle. From there, we generated some synthetic data that would be typically obtainable from an email service provider, as well as features that here at Locks would be able to extract from the historical data of these email campaigns. The model we used to create these predictions was a neural network model using computer vision. We used the pre-trained ResNet 34-layer convolutional neural network with a PyTorch API to extract image embeddings, which we then fed in to a gradient boosted tree model to get our prediction probabilities and recommendations. So we will load in some packages into our notebook, load in our respective data sets. We'll take a look at our data frame here. This first column is just our image path to the image. Here's our metadata. Here it is split out into separate columns for the year, make, and model. Here we have some metrics that would be typically collected by an email service provider of deliverability rates, open rates, click-throughs, abandoned cart campaigns, unsubscribe campaigns, and some campaign types and industries that we would be able to parse here at Locks Digital Group using some sorting, segmentation, and categorization algorithms, generally using natural language processing to group those into their respective campaign and industry. And here's a look at the embedding output from our convolutional neural network. Here they would want to see what type of metric they want to optimize for with this image. They're trying to optimize for a click-through rate in a promotional campaign. This is an automotive data set, so we use in the automotive industry. And here we can get some predictive analytics with this current image. It would have a 28% chance of being a click-through in the automotive industry with it as a promotional campaign. Here, our model is recommending these alternative images and their respective click-through probabilities. And the model would recommend alternate image number 1, as the 68% click-through rate is the highest among these provided here. And one caveat to note is that these neural networks are known as black box models, so it's hard to connect the reason why the model is recommending a certain image. A lot of it is lost in an abstraction in the neural network itself, but you can infer that it's because it's picking up on this being a convertible class, that we can connect that to that a convertible class of vehicle has a higher rate of click-through in a promotional campaign in the automotive industry. And so we can just check this one more time with some slightly different variables. If you were running a unsubscribe campaign in the survey category, maybe you're surveying why they unsubscribed, vice versa. We'll keep it in the automotive industry. And then here we still have a 20% chance of conversion rate for converting on this unsubscribe metric. And here are some alternate images and their respective probabilities. This would recommend image number 1 because it would have a 75% probability of converting on this unsubscribed metric. And thus the marketer would consider an image similar to this. It would also be based on, this model was trained on image classes, so that yet again, they would be considering using a convertible class of vehicle rather than this coupe sedan type here. And so obviously this is trained with a just sample data set we used from Stanford AI repository. This would be in practice trained to the historical data set of our whatever potential client and the images and industries that their clients actually used. So the results would be definitely very different in a production environment. And that concludes this part of the demonstration, part 2. We look forward to seeing you in our next installment, part 3, where we will show our model analyzing call to action buttons and giving predictive analytics in terms of the text content and the color of the button. Thanks for watching, and any questions, feel free to contact us here at Lox Digital. Thank you.